Welcome to Present Science Academy classes, and we are about to start with step 2 in the paper code. This is the paper code. The question paper code. This is the step 3 of year 2026. Okay, and these are the instructions and the time allowed. As you know, it's 3 hours. Maximum marks would be 180. Let's move on to the first question, and we are going to solve only the physics part. So it's given that an object is placed in front of a convex mirror at infinity. So the object is at infinity, and according to the Cartesian sign conventions, the sign of the focal length, we have to find the sign of the focal length and the image distance. Image distance is denoted by V. Now, this is the convex lens, and so let's say this is the convex lens and this is the principal axis. Let this be the optical center. So object is placed at infinity. Now the object is placed at infinity, and this convex lens is also called converging lens. This is the object that is placed at infinity, and we denote this object by AB. So this is the object distance. Distance between the optical center and the object is noted by U. Now all the rays coming parallel to the principal axis will be converged by this lens, and they will meet at a point which is called the principal focus. So all these rays will meet at a point which is called the principal focus, and the distance between the optical center and the principal focus is called focal length. Now let this, we know that as per the Cartesian plane that divides the plane into four coordinates, this is the origin. So in this case, the origin is the optical center, and the distance towards the left, right from the origin, this is the origin. So towards the left is taken as positive, right towards the right is taken as positive, and distance towards the left from the origin is taken as negative. So for convex lens, the focal length is always positive. This is positive. Now the image is the distance between the optical center and the image is denoted by V. So V is on the other side of the lens. This optical center is considered to be the origin. So towards this side, so this is the distance. Image distance is measured from the origin towards the right side, that is in the direction of the incident light. So this is also taken as positive. So image distance is also positive. So in this case, our option is option D. Let's move on to the next one. Okay, for question number 14, it's given that for verifying Ohm's law, we design an electric circuit diagram. So electric circuit diagram is the path in which the electric current flows continuously and in a closed loop. So there is an arrangement of different circuit components. So with respect to the resistor, what is the ammeter and the voltmeters position, and how means how they are connected with the circuit. So let me draw a circuit for you. Let's say this is a connecting wire. Let this be the resistor. This be the resistor. So this is the resistor. It can be any electric component as well. So let this be the key, and it's closed. Let this be the battery. बैठ जाओ, यहीं आएंगे. Okay, so let this be the circuit diagram, and the direction of current in this case will be from positive. So this is the direction of the current. Direction is flowing in this current is flowing in this direction from positive to the negative terminal. Okay, now ammeter. So ammeter is always connected in series. Series means that we have to connect ammeter's positive end. So let this be the ammeter, and its positive end is always connected to the positive end of the battery. So this is connected end to end in the circuit. So this is called the series. So this is connected in series. Now, if you have to find the potential difference, so potential difference is always across the ends of the resistor. So let this be two terminals A and B, and potential difference is always across the ends of the resistor. So across the ends of the resistor means we have to connect a voltmeter like this. So voltmeter is connected like this. So it's connected like this. So voltmeter is, this is called the parallel. So voltmeter is always connected in parallel and ammeter is always connected in series, and our correct option is ammeter is connected in series and the voltmeter is in parallel. So B is the correct option here for question number 14. Okay, for next question, that is question number 15, it's given in a resistive circuit. If the current is increased two times, the percentage in the amount of change in the amount of heat dissipated in the circuit. So we know that amount of heat dissipated in the circuit is given by the Joule's law, which is H is equal to I square RT, and this is called the Joule's law of heating. Now it's given that the current is increased two times. Let I dash be the new current. So this is increased two times. So new heat generated, I'm going to denote that with H dash. So H dash is equal to, instead of I, it's now new current. So I dash square into RT. Now I dash is 2I. So 2I the whole square into RT, which gives me 4I square RT. Now we have to find the percentage change. So before that, let's find out the change. So change in heat dissipated will be the final heat, that is H dash minus H, and H dash is 4 I square RT minus this is I square RT, which gives me this is 4 minus 1, which is 3 I square RT. Now we have to find the percentage. So how do we find the percentage change? Percentage change in heat dissipated. We know that the formula for that would be the change. This would be the change in heat dissipated. So change in heat dissipated divided by the original value of the heat. So change in heat dissipated by the original heat dissipated, or the initial heat dissipated. And because we have to find the percentage, this has to be multiplied by 100. Now this is the change. So this is 3I square RT, and original heat dissipated was this I square RT. So this is I square RT and multiplied by 100 to get the percentage. So this gets cancelled and we have 300%. So percentage of heat dissipated is 300% in this case, which is the option B. So this is option B for question number 15. Okay, for question number 16, it's given a positron enters a uniform magnetic field at right angles. So the action of the force experienced by the positron will be. Now, what is a positron? So positron is an antiparticle or subatomic particle of electron that has the mass equal to electron. So this has mass equal to electron, but the charge is positive and is this is positively charged. So charge is equal to an electron, but it's positively charged. So positron is a positively charged particle. Now it enters the magnetic field is in this direction. This is the magnetic field. We denote the magnetic field by B, and the direction of the positron is actually the direction of the current. And we have to find the direction of force. So for that, we are going to use the Fleming's left hand rule. And Fleming's left hand rule states that if we stretch the forefinger, middle finger, and the thumb of the right hand mutually perpendicular to each other, and if the forefinger, so if forefinger gives the direction of the current, so we have this uh, the forefinger, middle finger, and the thumb mutually perpendicular to each other. Let's say this is the So this is the direction of this is the forefinger, which gives the direction of the magnetic field. Magnetic field is noted by B, and this is the central finger, which gives the direction of the current. Current is denoted by I, and then the direction in which your thumb points when they are stretched mutually perpendicular to each other. These are mutually perpendicular to each other. So the direction in which the thumb points will be the direction of the force on the conductor or the motion of the conductor. Now, if we use this on our left hand rule, and according to this, let's consider this to be the plane of white sheet paper. So let this be the plane of your paper placed horizontally. Now, if you point your forefinger in this direction and the middle finger in the direction of the current of the left hand. So the direction of the current is upwards. The middle finger, so this is the central finger, forefinger gives the direction of the magnetic field. Middle finger is pointing upwards. Your thumb will be pointing into the plane of the paper. So this is the option C, into the page. So direction, this is the direction of force that will be into the page of the paper according to the Fleming's left hand rule. So this is option C for question number 16. For question number 19, which is a version in the region-based question. And the version says that a person suffering from myopia cannot see distant objects clearly, which is true. Because myopia is also called nearsightedness. This is called nearsightedness. Nearsightedness means you are able to see nearby objects. So you are able to see nearby objects in this case. You cannot see distant objects. Means distant means far away objects. So you cannot see distant objects. So according to the definition of myopia, this is true. Now, the reason it's given that a converging lens is used for the correction of myopic eye, as is confirmed weakness when virtual images of the object placed in front of it, which is false, because we do not use converging lens, which is a convex lens instead. So this is not used. We use concave lens. So concave lens is used for the correction of the myopic eye, because in this case, the image is formed in front of the retina. So for myopic eye, image is formed in front of the retina. Let me show you how. So let's say this is the eyeball, and let's say this is the eyeball. This is the lens. Now for a myopic eye, the image is formed in front of the retina. So these with the incident rays. For a myopic eye, the image is formed, these will intersect in front. So the image is formed in front of the retina. Now we have to get this image on the retina. Now image is formed in front of the retina because in myopic eye, the person is not able to see nearby objects, but it's able to see nearby objects, but cannot see distant objects distinctly. And because a person with this effect has the far point nearer than infinity, because his far point is nearer than infinity. So this is, let's say, his far point. This is the infinity. So his far point is now nearer than the, so his far point is now here, nearer than the infinity. So this is the far point. So the far point is nearer than the infinity. So we can say here that it's because the far point means the maximum distance up to which a person can see. So far point is here nearer than infinity. That means the rays of light coming will meet in front before the retina, that is in front of the retina. And to correct this, we have to now this was the far point, now it has reached here. So that means now we have to diverge the rays of light coming here to the retina, and this is corrected by using a concave lens here. So we use a concave lens here of appropriate power. Okay, now what happens? These rays will now be diverged. So these rays now be diverged to the lens. So these rays will now be diverged to the lens. These are now diverged to the lens, and now they are made to fall on the retina. And now these rays are made to fall on the retina here. Okay. So the far point is nearer than the infinity, and the rays from the far point that is nearer than the infinity are made to diverge. So it diverges. So that means we use a diverging lens, which is the concave lens, to fall on the retina here to the real and inverted image. Okay, so that means our option here should be assertion is true and reason R is false. So C is the correct option for question number 19. Okay, for question number 20, the version is magnetic field lines do not intersect each other, which is true. So no two magnetic field lines intersect each other, which is true. Now, the reason for this magnetic field lines are imaginary lines, the tangent to which at any point gives the direction of the magnetic field at that point. This is also true, but not the correct explanation. So explanation of this is, let's say this is a bar magnet, and we know that magnetic field lines emerge from the North Pole and merge at the South. These are the two magnetic field lines. These emerge from north and merge at south. Okay, now these are the magnetic field lines and these are imaginary lines. Now, if I take this point and if I have to find the direction of the magnetic field at that point, I draw a tangent at this point. The tangent at this point gives me the direction of the magnetic field. So this is the direction of the magnetic field, which is noted by V. You study that in higher classes. Okay, now if let's say two magnetic field lines, these two magnetic field lines, let's say intersect each other. Let's say these are the two magnetic field lines, let's say intersect each other. Now this is the common point for both these magnetic field lines, and for this line, the direction is given by the tangent drawn to it. So this is the direction for, let's say, this magnetic field line. Let's say this magnetic field line is L1, and okay, not this one. So this is the direction for the magnetic field line for this one. Now let's say this L2 is another magnetic field line. And direction for this will also be a tangent, but tangent will be in this direction. So this is the direction. So this is the direction one. This is the direction two. So for two magnetic field lines at same point, we cannot have two directions. It should be only one, which is not possible. So this is the correct explanation. That's why two magnetic field lines do not intersect each other. So this is not the correct explanation. The statement is true, but not the correct explanation of A. Correct explanation is this, that if two magnetic field lines intersect at a point, then at that point we have two directions, which is not possible. So our option for this would be that both are true, but R is not the correct explanation. So it should be B. Both assertion and reason are true, but reason R is not the correct explanation of assertion A. So this is option B for question number 2. Okay, for question number 24, it's asked when and where does a rainbow appear in the sky? So this is question number 4. And the solution for when. When does a rainbow appear in the sky? So it appears, it is formed after a rain shower. So answer for this is it is formed after a rain shower when drops of rain remain suspended in the air. So when? Now where? So where means it is always formed in a direction opposite to that of the sun. So it is always formed in a direction opposite that of the sun. Okay, now we have to draw a labeled ray diagram to show its formation. So we know that the raindrops they act as prisms. So let this be a spherical raindrop and let this be a white beam of light. Now let this be point A where it enters, and here there is dispersion. Dispersion means we get 7 colors which are violet, indigo, blue, green, yellow, orange, and red. So I'm going to show the most scattered and the least scattered color which are violet and red. So at this point it's dispersion. This is the dispersion splitting of white light into 7 colors, and at this point it's the reflection, but it's inside the drop, so we call it internal reflection. So this is internal reflection. We also call it total internal reflection. Now, at this point, that is the point C. So this is point B where the total internal reflection is happening. And at point C, there is a refraction. So the light rays are coming from the water into the air. So this is the reflection. And let's give the direction. So at this point, this is the reflection. So these are the three phenomena involved in the formation of a rainbow, and let's label it as this is the ray diagram for the formation of a rainbow. Okay, now next is what is scattering of light. So we know that when light it enters the air, so when it enters the air, there are particles of different sizes, and the very large size particles or the molecules, which we also call the collided particles, they scatter the light in different directions and change the direction of propagation of light. So we can say that for this, we can write what is scattering of light. For scattering of light, our definition will be, so scattering of light. And for scattering of light, our definition is the phenomenon. So this is the phenomenon of the change in the direction of propagation of light. And this change in the direction of propagation of light is caused by particles of large size. Is caused by, we can say that the large sized molecules or the collider particles that remain suspended in air. So this is what is scattering of light. Okay, now what is the next part? Why does the sky appear blue? So it appears blue because of the scattering of light. And now here, so this when sunlight, so for this our answer should be when sunlight it passes through atmosphere. Okay, now there are particles of different sizes, but in this case we are going to consider only the very fine particles. So this very fine particles, their size is of the order of the wavelength of blue color. So very fine particles, which we say the very fine particles or the minute particles in they pass through the atmosphere. Now fine particles. So when sunlight passes through the atmosphere, very fine particles in the air. They scatter. Now they scatter light of shorter wavelength, which is blue, because their size matches with the order of the size of the blue light. So light of shorter wavelength, which is blue color, and we can say more than the red color. So blue is scattered more than the red color, which is of longer wavelength. So this is the reason. So red has longer wavelength. So when sunlight passes through atmosphere, very fine particles in the air scatter light of shorter wavelength, that is blue color, more than the red color, and that is sky. That is why sky appears blue. Okay, this is the answer for question number 24. Let's move on to the next question. Okay, for next question, we have the VI graph. So V is the potential difference and I is the current for two conducting wires A and B, and both the wires are of same length and same diameter. So which of the two is made of a material of high resistivity? So let's consider this VI graph, and now this conducting wire A, its slope is this angle. So B wire has more slope, and we know that now the slope here is, so slope here is equal to V by I, and V by I is equal to R. So that means if I consider the slope of wire B, it will give me the resistance. Now the slope of wire B is greater than the slope of A, and the slope is equal to the resistance. So that means the resistance of wire B is greater than the resistance of wire A, because the slope of wire B is greater than the slope of A, and slope is equal to the resistance for this VI graph. Now it's asked which of the two is made of a material of high resistivity. So in this case, we can write that for the conductor of same dimensions means here the length and the diameter are same. So we can write here our option will be C. So for from the graph, we can write here. So write that from the graph, slope of wire B is greater than slope of wire A, and hence wire B has greater resistance. Okay, so by this time we know that wire B has greater resistance. Now if wire B has greater resistance, and if the conductors, both the wires have same dimensions, and for we can say the conductors or the wires of same dimensions means the same length and same diameter, but of different material. Same dimensions means length and diameter. Greater is the resistance, greater is the resistivity. Greater the resistance, greater is the resistivity. So that means we have given the reasons. So which of the two is made of a material of high resistivity? So wire B is made of a material of high resistivity. Okay, so our answer is wire B. Okay, for next question, that is question number 31. It's given that a student has focused the image of an object of height 3 centimeter. So object of height 3 centimeter, this is part A. So object is height is noted by h, and it's always erect, so it is 3 centimeter on a wide screen using a concave mirror. And for the concave mirror, the focal length is 12 centimeter and it's negative using the sign conventions, because for the concave mirror, this is the concave mirror, its focal length, its focus is in front of the mirror, and this is the pole. The distance between the focus and the pole is the focal length, and this side is a negative side. So focal length is negative, which is 12. The distance of the object, so distance of the object is denoted by u, and it's also in front of the mirror, so it is negative 18. We have to find the following. We have to find the values of distance of the image. So distance of the image is denoted by v. So that means we have to find out v, and height of the image. Height of the image is h dash. Okay, let's use, this is a mirror, so let's use the mirror formula. So I'm going to use the mirror formula. So using mirror formula, so mirror formula is 1 upon v plus 1 upon u is equal to 1 by f. So we have to find v. U is negative 18, f is negative 12. Now this plus or minus is minus, we can take, so this is also minus 1 by 12, and 1 by v is equal to negative 1 by 12 plus 1 by 18. So 18 to the is 36, which is the LCM, and this is 12 3 negative 3 plus 2, which is negative 1 by 36. So that means v is equal to negative 36. Negative means that it's formed in front of the mirror and is at a distance of 36 centimeter in front of the mirror. Okay, now we have to find out, second is we have to find out the image height. So for this was his first part, and let's find out. So we know that magnification is given by h dash upon h is equal to negative v upon u. So we are going to use this combination. H dash is the height of the image, h is the height of the object, which is 3, and negative v. V is negative 36. Use the sign convention 18. This gets cancelled. So 3 6 r is 18, 6 6 r is 36. So height is negative 6. Negative means that the image is inverted and it's 6 centimeter in size. That is, this is the height of the image. Okay, let's move on to the or part. What is the power of a lens? Okay, moving to part B. Now this is or part B. Now the power of a lens. What is the purpose or what is the function of the lens, whether it's a concave lens or the convex lens? So the function of this concave convex lens is to convert the rays of light. So they bring the rays of light at one point. Now, more they bring the rays of light at one point, the its focal length will decrease, because this point is the focus. So more they convert the rays of light, more will be the focus near the optical center. So that means that the focal length is decreasing, and the degree of convergence for this lens is called its ability, which is called its power. So more it converges, more is the powerful lens. Similarly, for the diverging lens, more it diverges the rays of light, more is its power. So its function is to diverge the rays of the light. So more it diverges the rays of light. For these rays of light, if we produce them backwards, they will intersect here, which is the focus. So distance from the optical center and the focus is the focal length. So more they convert the rays of light, so more they convert the rays of light, more nearer will be the focus and less will be the focal length. So focal length decreases and the power of the lens increases. So we can write that the power of a lens is the ability of a lens to convert or diverge the rays of light. So power of lens. So power of lens is the ability of a lens. So lenses are of two types. The convex lens will converge and the concave lens will diverge. So ability of the lens to convert or diverge. And what are they diverging and converging? They are diverging the light rays falling on them or falling on it. So that is the power of the lens. Instead, you can also say for this, you can also write the degree of convergence, how much they are converging. So what is the degree of convergence or divergence of a lens is called power of a lens. How much they are able to converge. Okay, now what is happening next? So, okay, we are done with the power of the lens. The focal length of the lens is minus 10 centimeter. Right, where we have to write the nature of the lens and find its power. Okay, next. Now the power of the lens is given by P is equal to 1 by F, where F is in meter. It should be in meter. This is the power of the lens, which is the reciprocal of the focal length, and focal length should always be in meter. Now the focal length of the lens is minus 10 meter, which means that it's a concave lens because the negative focal length is for concave lens according to sign convention, and it should be always in meters. So this is negative 1 by 10 meter. Okay. And write the nature of the lens and find its power. So what is the nature of the lens? It is because concave focal length is negative, so it is concave, or we say diverging lens. Okay, that is the nature. This is the focal length. We have converted it into meter. Now we have to find the power, which is 1 by F, and F should be in meters. So this is equal to 1 upon negative 1 by 10. That is equal to negative and meter inverse, which is called diopter. So this is then diopter is the power of the lens. Okay. According to the new sign convention, what will be the sign of magnification in this case? So sign of magnification. What will be the sign of magnification? Sign of magnification will be positive. Okay. Because we know that the magnification is given by for the lens. For the lens, the magnification is V by U. And this magnification, the convex lens will have to magnify the object. So that means the objects are to be magnified so that the magnification has to be positive. So in this case, the sign of magnification is positive. So for question number 33, we have to explain the meaning of overloading. So what is overloading? Overloading means when excessive current flows in the circuit. And there could be different reasons for this. So the definition of overloading means that excessive current flows through the wires. So we can write for the definition overloading. So overloading happens when an excessive excessive amount of electric current flows through wires. That is overloading. Okay. So this is overloading and list two possible causes. So possible causes. So list two possible causes. So I'm going to mention two causes for this. So this is exactly how you should answer this question. And two causes. When does this overloading happen? When the live wire and wire come in contact with each other. This is possibly due to the melting of the insulation of line and the neutral wire. So line and neutral wire, they come in contact with each other. Each other. Okay, this could be the reason, and for this, the reason could be that the insulation of the wires melts because of the excessive use or because of the temperature. Or overloading also means that we are connecting too many appliances to a single socket. So connecting too many appliances or gadgets to a single socket, like if you connect a geyser or a room heater or any other device to a single socket. So the excessive current will flow in the socket, and if the socket has a lower fuse rating, that will melt the insulation of the wire, and then the live and the neutral wire will come in contact with each other. So, or the third reason could be the accidental hike in voltage supply. So, third could be accidental hike in supply voltage, and we know the supply voltage to our home is 220 volt. So somehow if it exceeds the greater than 220 volts, so that could be the possible reason for the overloading. Okay, now what could be the preventive measures? How do we prevent if this happens? What would be the preventive measures that we should use as a safety measures? And the first one is use wire properly, making and properly. Okay, now second would be do not connect too many appliances to a single socket. So the causes could be the preventive measures. Just mention that do not connect too many appliances to a single socket. Okay, and what could be the third preventive measure? We have to use the fuse. You fuse as a safety device. Use fuse as a safety device so that whenever the temperature increases due to excessive current, the fuse wire melts and breaks the circuit. So fuse as a safety device. So this is how exactly you should answer this question. And let's move on to the next one. Okay, for our next question, that is question number 36. It's given that an object is placed in front of a convex lens of focal length f. And if the distance of the object from the lens is 2f, we have to draw a ray diagram to show the formation of the image. Now, 2f means that the object is uh, at a distance that is equal to the radius of curvature. That means the object is at center of curvature. So distance between 2f and optical center is the radius of the curvature. And we have to draw the ray diagram for this. So let's draw the ray diagram. This is part A using a convex lens. So let's draw a convex lens here. So let's say this is the convex lens. Let's say this is the optical center. Then we after that laptop is okay, this is the principal axis and optical center is denoted by O. So this is O. This is the optical sector, this is the convex lens, and this is the first principal focus that is different from the optical that this is the optical application process, which is the internet one. Now, so distance between the optical center and focus is the focal length, and this is the second principal focus. So this distance is twice of the focal length, and we know that twice the focal length is equal to radius of curvature. So this is the center of curvature at this point. So object is placed here at twice the focal length, which is also called the center of curvature. And we denote the object by AB, and the arrow is pointing upwards, which means that the object is uh, standing erect. So this is the center of curvature. Okay, now then let's draw a ray parallel to the principal axis and another ray that's passing through the center of curvature. And this ray, when it goes, the one that parallel to the center of curvature is passes the second principal focal F2. It will intersect the ray coming from the optical center at this point. So this is the point where the ray intersects, and this is where the image is formed. Okay, and in this case, I'm going to put the arrow downwards. That means that the image is inverted and it's noted by A dash B dash. And this is exactly where the second principal focus or the second center of curvature is. So this is where the image is formed. This is the inverted image. Okay, this is a ray diagram, but make sure you give the direction for the rays, else the marks will be deducted. Okay. So we have drawn the ray diagram to the formation of the image. Write down the value of magnification. Now we know that the magnification in case of lens is given by V by U. Here the image distance is this and object distance is 2f. So both are 2f. So that means the image distance and object distance are same. So that means the magnification is here it's -1. Negative is for the inverted image. That means that the image is inverted, and 1 means that it's equal to the size of the object. So you can write down the magnification, so put the negative sign for the inverted image and 1, which means that the image distance is equal to the object distance. So magnification is negative. Negative sign is for the inverted image. Okay, write the value of the magnification, then get A part. So this what A part let's move on to B now. A student has focused the image of a candle on a flame. So image of a candle flame on a wide screen using a convex lens. Situation is given below. Length of the flame, that is the height of the object. This is part B. So length of the flame is 2 centimeter. And the focal length, this is a convex lens. So for focal length, the convex lens is positive. So the convex lens here is, so convex lens is 12 centimeter. So this is 12 centimeter, which is positive. So height and the distance of the flame from the lens, which is 16 centimeters. So this is U, and U is in front of the lens. So this is negative. Now, what all we have to find out? We have to find the distance of the image, which is V, length of the image, which is H dash. So we have to find V, and because this is a lens, so we have to find V and H dash, which is the size of the image. So this is a lens. So we are going to use lens formula. So using lens formula, and lens formula is so let's put in the value at 15. 1 by F is 12. So negative negative is positive. 1 by V plus 1 by 16 is equal to 1 by 12. This gives us 1 by V is equal to 1 by 12 minus 1 by 16. And LCM of 12 and 16 is 16 twos are is 32. 16 threes are is 48. So LCM is 48. This is 4 minus 3, which is equal to 1 by 48. This is not negative. This is 1 by 48. So that means V is equal to 48 centimeter, and plus means that it's on the behind the lens, and it's at a distance of 48 centimeter from the lens, behind the lens, or on the other side of the lens, we say. Okay, now so V is 48. Now we have to find out, we know that magnification in this case is given by this h dash upon h is equal to V upon U. So let's use this combination h dash upon h, where h is the height of the image or the size of the image. So we have to find out h is given, which is V 48 negative 60. Okay, this is 16 divided 48. So h dash is now equal to negative 6. Negative means that the image is inverted and it's 6 centimeter inside. So height of the image or image is 6 centimeter in size, and negative is for the inverted image. So we have found the length of the image, which is h dash. And let's move on to the next question. Okay, for question number 39, which is the last question of this set, we have to consider the following electrical circuit diagram with identical resistors of 3 ohms each that are connected as shown in the figure. So these two are in parallel, these three are in parallel, these four are in parallel. Now, if the reading of the ammeter is A1 is 1 ampere, so here the reading is 1 ampere. We have to answer the following questions. Okay, so what is the relationship between the readings of A1 and A3? So let's say if the current here, the current is 1 ampere, so when the current passes through these three, here it will come as 1 ampere total current. Now the current is distributed equally in these three, and it comes out to be 1 ampere here. Is distributed equally in all these four, and it comes out to be 1 ampere here. Okay, so that means A3 and A1, it has the same readings of 1 ampere, and reason is that they are connected in series. So for first one, A1 is equal to A3 is equal to 1 ampere, as they are the ammeters connected in series. As these are the ammeters, they are connected in series. Okay, the first one is done. What is the relationship between the readings of A2 and A3? So this is A2 and this is, okay, here, because these are the identical resistance, so the current is equally distributed here in all the three. So these are four, so here each of them will have 1/4 of the current. So 1/4. So each of them will have 1/4, 1 by 4 ampere of current. So this is 1 by 4 ampere here, 1 by 4 ampere here, 1 by 4 ampere in this one, and 1 by 4 ampere in all each of the four resistors, because they are identical. So the total current going in for these was 1 ampere, and 1/4 is distributed equally here. So that means this will give us the reading of the 1/4 ampere of current. And here the current will combine 1/4, 1/4, 1/4 will combine, and it will come out to be 1 ampere here. So the readings of A2 and A3, what will the readings of A2 and A3? So in current, A2 will have 1/4 of the reading of A1, because it has 1/4 current. So, sorry, A3. So A2 will have 1/4 the reading of A3. Now determine the reading of voltmeter V1. Where is voltmeter V1? So V1 is considered here across these two resistances. So for C, so for C, and this is for, we are going for voltmeter V1. So volts for voltmeter V1. So these are resistances connected in parallel. So resistance here will be Rp. That is 1 by Rp is equal to 1 by 1 3 plus 1 by 3 plus 1 by 3, which is equal to 2 by 3. So that means this is 1 by reciprocal of the resistance in parallel. So Rp is 3 by 2 ohm. And we have to find the reading of voltmeter V1. So that means we have to find the potential difference here. So we have Rp and current here. The current will be distributed equally. It's coming out to be 1 ampere. So 1 ampere current is going to both these. So for both these, because we have treated this as a combination, so 1 ampere current will be going in both these, and we know that V is equal to IR. So here the reading of the voltmeter V1 is equal to I is 1A, and this is 1 ampere. So resistance is that which is 1.5. The reading of this voltmeter V1 will be 1.5. So we have got the reading of 1.5 volt for voltmeter V1, which is connected in parallel across these two identical resistors, 3 ohm and 3 ohm. Okay, moving on to the OR part, we have to find the total resistance of the circuit. Okay, to get the total resistance of the circuit, okay, let's get the resistance for this part now. So these two are connected in parallel. So its resistance will be 1 upon Rp. Let's say it's R1. Resistance is R1 for these two resistors. Okay, so I'm considering the total resistance for this circuit is R1. So 1 upon R1 is equal to 1 upon R3 plus 1 upon R3, which is 2 by 3 ohm, and R1 is now 3 by 2 ohm. Okay, let's consider the resistance for this as R2. Okay, which are also connected in parallel. So 1 upon R2 is equal to 1 by 3 plus 1 by 3 plus 1 by 3, which is equal to 3 by 3, which is equal to 1 ohm. So that means R2 is equal to 1 ohm. So the net resistance of these three is 1 ohm. This has come out to be 3 by 2 ohm, and these are four identical resistors connected in parallel. So net resistance of these four would be, let me consider this as R3. So 1 upon R3 is equal to 1 upon 3 plus 1 upon 3 plus 1 upon plus 1 upon 3, which is 4 by 3 ohm. But this is not the resistance R3. R3 should be the reciprocal of this. This is 3 by 4 ohm. Okay, now we have our circuit like this now. So this is R1, this is R2, this is R1, this is R2, and this is R3. So R1 is 3 by 2 ohm. So this is 3 by 2 ohm, and R2 is 1 ohm, and R3 is 3 by 4 ohm. Now all these are connected in series. So let's find out the total resistance of the circuit will be the sum of R1 plus R2 plus R3, as they are in series now. So this is 3 by 2 plus 1 plus 3 by 4, and LCM here is 4. So this is 6 plus 4 plus 3, which is 6 plus 4 is 10. This is 13 by 4 ohm. So 13 by 4 ohms means it's 4 threes are 12, 2 and 5. So 3.25 ohm is the total resistance of the circuit. Okay, so with this we are finished with this set. Do like, share, and subscribe. Thank you for watching.